Bismillahirrahmanirrahim. Hello and welcome to Rahman Digital Production. This is lecture number 23 of Physics 5054 of GCE. Ladies and gentlemen, in the last lecture, we studied the concept of density in greater detail. Today, we are going to learn how to find the density of liquid or the density of regularly shaped object. Today we will also try our best to finish this chapter theory and we will turn our focus to the exercise. We will start inshallah exercise as well if it is possible and the time is allowing us. So let's start with the measurement of the density. If you want to find this, this is an experiment given on page number 61 of your book, and the topic of this, the heading of this experiment is to determine the density of a liquid. Ladies and gentlemen, you need a retort stand, burette, and a beaker along with a balance because you have to measure the mass. Yesterday, ladies and gentlemen, I told you that density, which is denoted by rho, is equal to mass per unit volume. Now, for finding the density, we need two things. One is called the mass, and the second one is called the volume. For those two things, we need uh, this setup as well as a balance on which we have to find the mass. Number one step is find the mass of a clean and dry beaker, and that will be M1. We will call it as M1. Now in the second part, run volume of the liquid, and that will be V from the burette into a beaker. This is the second step, that you have to pour the liquid, whatever liquid you want to find the volume of. So the liquid will increase the mass of the beaker, and the third part and the third step is to measure the combined mass, and that will be M2 of beaker and liquid. That's it, ladies and gentlemen. You have to take, and then using the formula Rho is equal to M2 minus M1 divided by V. If you are taking it in grams, so gram per uh, meter cube या centimeter cube. So you are taking it centimeter cube, or if you want to convert it into kilogram, then you have to multiply with 1000 and kilogram per centimeter cube. So this will be the formula, and here then you have to say that meter cube, because you are multiplying it with the 1000. So this is the but one precaution you have to keep in mind while taking the reading from the beaker. Your eyes must be uh, parallel to this the base of the meniscus of the liquid. Otherwise, you will get a wrong answer. Okay, that was the whole story. How to find the volume. And this question is very important as far as paper number 4 ATP alternative to practical is concerned. When we start it, inshallah, then you will see that these sort of questions are in abundance in the paper. So learn it. Now that was one way of the measurement of the density. If we want to find the density of the liquid, then you have to do these activities. You have to perform these activities. Now, if we want to find the volume of regular shape objects, then you have to do other activities. Now this is a block which is in the form of cuboid. Uh, what is cuboid and what is cube? There is a difference. If all the sides of a cube are equal, then it is called cube. But if the length, breadth and width are not equal, it is cuboid. Here we are denoting the height with h and the length with L, and B is the breadth. So if we want to find the volume of this, first, because we need, first number is cuboid. This is a regular shape. So we have to use the formula rho is equal to m divided by v. How we will find the volume? First we have to measure the mass of this block through a balance, and then we have to find the volume is equal to L cross B cross H. L cross B cross H. Uh, and then you have to put all these values inside the formula which I wrote in advance for you people, and that's it. Now what about the second shape, which is a cylinder? In cylinder we have to find the diameter, and you know, ladies and gentlemen, that diameter is equal to 2r. So sometimes the people are writing the formula in term of radius, but because we are finding here the diameter, so we are using the diameter. Now for the cylinder, you have to use a formula to find the density. For cylinder, we will use rho is equal to mass. That is very easy. And then we have to find the volume. So how we will find the volume of the cylinder? So V in this case is given as pi d square, divided by 4 into L, where L is this, you have to use a balance meter rule to measure the length. You can also use the uh, mm, vernier calipers as well for precise measurement. And here again you can use the diameter or radius. We learned that in the first topic of this course. If somebody is not understanding, then go to the previous video of first or second video. I don't exactly remember, but it was in that. So we have to find the d. This is the d square. Pi is a constant, 3.14159, like this is a value, and then all the values with you. When you find the volume, you have to put it here. You have to find the mass by balance, then you have to put it there. The third one is of the sphere. How to find the density of a sphere? Again, I will write a formula that is m divided by v, and volume of the sphere is 4 over 3 pi into d divided by 2 whole square. Here you can write the r square as well, because d divided by 2 is equal to r. From here, d divided by 2 is equal to, so 4 over 3 pi r square. Then you have to find the r and double it, because we need in the formula is diameter. So you can find these values as well. If you are finding rho is equal to mass per unit volume in gram per centimeter cube, then you have to use this one. But if you want to find it with the mass per unit volume in kilogram, then you have to multiply it with 1000 kilogram per meter cube. So remember, in both cases, whatever data is available, according to that data you have to respond. uh, that's it, ladies and gentlemen, how to find the uh, density of regularly shaped or of a volume. That is very easy, and it will help you a lot inside the ATP. We will do inshallah ATP alternative to practical as well. Ladies and gentlemen, we are doing all these theoretical portion because this is used in the exercises. So then if I am directly writing these steps in the exercises, then the students are asking that how. For that, how I am explaining this in advance, learn it and utilize your knowledge in the exercise. Very soon we will turn to the exercise. Now our last topic of this unit number 4 is the topic number 4 is the relationship between density and flotation. What does it mean? It means that which thing will be floating inside which liquid. There is a question, and this question being asked very frequently by the uh, teachers from the students, that why a small needle can sink in the water but such a big uh, block of wood is not floating on, not sinking down in the water. What is the reason? If you are putting a small needle inside the water, it sinks down, but more bigger volume of a wood, when immersed in the water, it is not sinking down and it is flotation. So we will find a relationship between density and flotation. Ladies and gentlemen, this is a lead block and this is water. Now, in the first case, this is mercury. Uh, this is water, sorry. This is water and this is the lead and this is the mercury. This is the lead, sorry, and this is the mercury. Now, in this case, we see that the lead block is floating on the surface of mercury, but that lead block is sinking inside the water. Why it is so, ladies and gentlemen? We have to take in account the densities of the material. For example, the density of lead is equal to 11,000 kilogram per meter cube. Density of density of mercury is 13,600 kilogram per meter cube. I am writing one thing, then explaining it. Density of water is equal to 1000 kilogram per meter cube. Now, keeping in view this data, we will determine that why lead is floating on the surface of mercury and sinking in the water. Ladies and gentlemen, keep in mind this relationship. If the density of one object is greater than the density of another object या liquid, then it will sink down. For example, in the case of density of lead is 11,000 and the mercury density is 13,600 kilogram per meter cube. So it means the density of lead is less than the density of mercury. So it will not sink down. But in case of other, 11,000 of lead is greater than the density of water. Yesterday, I shown you a table in which the densities of liquids, gases, and solids were given. So study that and see that which thing can float inside which liquid. In this case, this density of lead is greater than 1000, so it will sink down inside this water. But because the density of lead is less than the density of mercury, so it will not sink down inside the mercury. So if now the question is that why a small needle is sinking down inside the water, so the density of that iron needle is much more greater than the water, so it is sinking down. But if we find the density of a block of wood, that would be less than the density of the water, so it will float on the surface of water and it will not sink down. So that is the whole story about the theoretical portion, and whatever the CIE examination section is giving in the theoretical portion. Hopefully you have cleared on this concept. Now we are turning our focus to exercise 4, and you know that the exercise is in two portion. One is called the multiple choice question, MCQs. So multiple choice questions mean that they will give you the four answer and then you have to respond. This is section number A, and that is the uh, listen carefully that you have to. I will share and you can see that from the uh, questions. Multiple choice question. First one is saying, when using a measuring cylinder, one precaution to take is uh, check the check for the zero error. No, it is not the answer. We don't have to check because I told you one precaution is the position the eye in the line with the base of the meniscus. So we discussed it, and that is the answer in this question. That is D number part. B number part is saying look at the meniscus from below the level of the water surface. No, not below. Obtain more reading by looking from more than one direction. No, it is not. Because from more than one direction you cannot. The D part is saying position the eye in the line with the base of the meniscus. Well done. That is the D of the first part is option is D. So I am writing the first MCQ is D answer. The second MCQ is saying that is a numerical type of scenario. So listen and understand. The mass of an empty measuring cylinder is 60 gram. So M is equal to 60 gram. Yes, we have to take that is 60 gram, and then what they are doing, when 30 centimeter of olive oil is poured in it. So mass of olive oil is equal to what? That is given as 87.6 gram. 87.6 gram. Now in the next portion they are saying the total mass is 87.6. The total mass is, this is the total mass. Total mass is this, and mass of olive oil is given as 30, is given as 30 centimeter cube. Sorry, volume is given as volume of olive oil is 30 centimeter cube. Now they are asking that the density of olive oil in gram per centimeter cube is, they given us three option, and you can see that from the given example. So let us solve this question. Density is equal to mass of olive oil. So we have to find first the mass of olive oil, and that is 87 minus 60. 87.6, 87.6 minus 60 gram, 60.7 gram actually they given us. See, no, 60 gram. So it means that 60.0 gram when subtracted from 87, it will give you uh, zero point 0.6 and 7 and then 27.6 gram is the mass of the olive oil. Now density is equal to, I am writing rho is equal to mass per unit volume. So mass is 27.6 and volume is given as 30. So because mass is in gram and that is in centimeter cube, so you have to calculate it and it will give you 0.92 gram per centimeter cube. And that is the ultimate answer. And the answer in this case is B part. B option is the correct answer. B option is the correct answer. Okay, the third number question is saying MCQ. A rock on the moon has a mass of 0.5 kilogram. Mass on the moon is 0.5 kilogram. This is number third. And it is brought to the earth where the gravitational field is stronger on the earth. So the rock will have less mass and less weight. Ladies and gentlemen, I told you that mass cannot be changed anywhere. If you are on the moon or on the earth or everywhere, so less mass and less weight, that is not absolutely correct. It is wrong. B number part is saying less mass and the same weight. No, it is also not correct. Mass cannot be less. Whenever it is written less, you don't have to check the second option. The same mass, yes, it is, and the same weight, no, because weight on the moon is different from the weight on the earth. Actually, it is 6 times. So, D part is saying the same mass, correct, and more weight, yes, because gravitational pull on the earth is more than the gravitational pull on that object on the moon. So, it will have the same mass and more weight. So here the option D is the correct option. Option D is the correct option. Ladies and gentlemen, that's it for today. Tomorrow we will turn our focus to the structure questions. Those are very important question, and tomorrow we will inshallah finish this chapter, and if the time is allowing us tomorrow, so we will start a very very important chapter, that is turning effect of forces. So stay in touch and subscribe my channel. uh, Press the bell icon as well, so immediately you will be informed when I upload the new video. Thank you very much. Allah Hafiz.